Alright, in this video, we're going to take a 200 gram, 20 centimeter plastic disc, and we're going to spin it on its axle through its center by an electric motor. And we want to figure out what torque must the motor supply to take the disc from 0 to 1800 RPMs in 4.0 seconds. So with any rotational dynamics problem, similar to rotational kinematics, we want to start by listing our givens. So we know the mass of the disc, which is 200 grams. We also know the radius. It says 20 centimeter plastic disc. Let's assume that we mean the radius there. That's not as explicit as it should be. Sometimes you're going to be given diameter, sometimes you're going to be given radius. Let's assume for this problem that's the radius. But pay attention to that. Now, what's the importance of this information? This tells me the mass distribution and size of the disc. So this will be information that I can use to find the moment of inertia of that disc. Now, what else do we have? We have that it starts with an angular velocity of 0, and it goes to a final angular velocity of 1800 RPM in a time interval of 4 seconds. And we want to determine what is the torque? With what net torque must the motor apply? Now, there are situations where we're going to have to account for friction as a resistant torque, but in this case, we're just finding the net torque. We don't have any information to quantify friction, so we can assume that it doesn't factor into this problem. Okay, so in general, what equation can I use to solve for net torque? Well, I know net torque will be equal to the moment of inertia times the angular acceleration of the object. Now, if we look at what we're given, here, by given the disk and the mass and the radius, that's going to be information to solve for I. And omega, initial, final, and time will be information I can use to solve for alpha. So in the way that I approach this problem, I can find I can find alpha. And those together are going to tell me the net torque. So let's do it separately. So I'm going to solve for I down here. So I look at my table for a disk. Let's see if I have it. A solid cylinder, that would be my disk. So my moment of inertia about the center is 1/2 mr squared. This one we're going to use a lot. So, and I want to be in standard units. So 200 grams becomes 0.2 kilograms. 20 centimeters becomes 0.2 meters. So 1/2 times 0.2 kg times 0.2 meters squared. Let's get your calculators out. All right, that'll give me a moment of inertia of 0.004 kilogram meters squared. So I found I. Now I'm going to want to find alpha. Let's do this calculation over here. So I have omega initial, omega final, and delta t. I want to find alpha. So I can use the first equation. Omega final is omega naught plus alpha times t. This is 0. So alpha will be omega final over the time, or delta t, be consistent. Now notice I'm in standard units, kilograms and meters squared here, so I have to convert these to standard units. So my omega final, which is 1800 RPM, now if I want to go from revolutions to radians, I multiply by 2 pi. And I want to convert minutes to seconds, so divided by 60 seconds. So my omega final will be 188.5 radians per second. So we'll continue on. Alpha will be omega final, which is 188.5 radians per second, divided by the time interval, which is 4.0 seconds. So I get an alpha 46.0 0.54 radians per second squared. All right, so I have alpha. Now the net torque, now if I had multiple forces, the net torque, remember, is the sum of all torques. But I don't. I just have the torque exerted by the motor. So this just is the net torque. Now I substitute my I value, my alpha value. So I get the net torque about that axis by the motor is going to be 0.186 meter newtons. And that's that. Now notice, what really is the link here between kinematics and dynamics? Just like it was first semester with acceleration. Alpha really is our key. We use our kinematics here to find alpha. We use our distribution of mass to figure out I. And then the net torque is based upon the force. So really this is the key quantity when we have a problem that integrates kinematics and dynamics. It's alpha that's always going to be the key there.